Here's Anatoly again, and in this video I'd like to show you something that might help you and save some time at work. So assume we have a datasheet for some semiconductor device, and we need to track down and digitalize some of the plots here. And in this particular example, let's take something like RTS on. Yeah, this one I think will do just fine. And normally what people usually do is using websites like webplot digitizer or something like this, and it is really good, but I think it's rather time consuming. So I have a little bit different approach and I would like to show it to you. So let's take a screenshot first and then paste it into the Inkscape or some other graphic editor which can work with vector graphics. So first of all, we need to create a rectangle, a box that will define our grid. It doesn't matter which point here we will take because we'll also put the coordinates. So we created it, and now let's create just one line. So we need to create a spline, a curve. So I create a line and then I just drag it like this until it matches with the plot here. Okay, so I save it and then I need to open it in Python. And I created a class called PyDS, which stands for Python Datasheets. And here we need to put the name of our file and then the number of points we need. Let's say 5. And let's call it A. Okay, we created the object and now we can also use the function here, plot all. And we see that we specified the number of points 5. Let's put maybe 15. And now we also need to define the grid. First of all, we need to say where it starts, what x and y, and what is the height and what is the width. So x is 100, y is 5, height is 5, width is 50. Now I think if we compare it with this one, with the original plot, let's take this out. So it starts somewhere at 19 milliohms and I think it's something like 15-20 amps, and then it goes all the way to 225 and something like 23, 22. I can see it here. I can also match it with the x from 0 to 200 and then y limits from 0 to 30. Okay, so now we have the first one. Okay, let's create the second one. So we copy this one, drag it down, or no, let's draw another one from scratch. So we create the line and then drag it a little bit to make it a spline. Also the color here doesn't matter, but I want to see it on the top of this black curve. And yeah, I save it and we see it instantly appeared here. If I drag it and import here, it also changes. So let's bring it back and let's draw the third one. Again, the color here doesn't matter. So we just want to see it here on this black plot. I save it and yeah, I think it matches in matter. And what interesting is that we can also select the number of points as I showed before. So we can make it just 2, we can make it 3, we can make it 30, and then it becomes very smooth. So for now, this class doesn't support the logarithmic data, but I'm going to include it at some point. And okay, we have this plot. How do we take the points? how do we take this curves and save it somewhere. Actually, this class PyDS has another method called values, and here we just put the number of the spline. We selected either X or Y. It can be 1 and it can be 2 because we have 3 plots. We cannot use 3, of course, so we can take Y values and X values, and let's just create here maybe 3 points, or maybe even 10. And now we can see that the values are matching what we see here. If you want to use it, just let me know in the comments below. I'll share it in my GitHub. And thank you for watching.